Hello, this is part three of week four. I'm redoing it because I've heard that it did not take last time it did it without volume, so I'm trying it now. Hopefully, it got the volume. So we talked about heat sources and how do we bring heat into the house. And there is a video that I'm including into this Blackboard about geothermal. I hope you really watch it because it has really good information about having a source, using the earth as a source for heat, which I think is very cool. But for if you have a hot water system and you would like to distribute the heat around the house, you might want to use a heat distribution system using radiators. These here are baseboard radiators. They are very uh, common and very inexpensive. And you can see, if you look at this radiator here, you can tell that the hot water is coming into the first pipe, the first radiator, second radiator, and a third radiator. Then the radiator will release the heat, and the colder water will come into this pipe. Becomes a manifold for colder water. It's a little bit darker here, and same thing from the second radiator and the third radiator. This system is called the two pipe system for hot water. It's very good way to have even distribution of heat. So in this, if you are going to use baseboard radiator, and we'll talk about that more when it comes to piping, is what kind of configuration do we have? Do we have a one pipe system or two pipe system? Do we connect the pipes in series or in parallel? In this case, we are connecting them in parallel, which is very good connection because it does distribute the heat evenly. And you can tell that all three radiators here, they get the same temperature, water temperature, and the same pressure. And if we connected this pipe from here to here and from here to here, probably this radiator will get a lot of the heat, second one will not get as much, and the third one will get almost nothing. So we do not want to connect the radiators in series. Again, this just gives you an example of one appliance or one way to distribute the heat, which is radiators. Okay, next one. Let's go to the next slide. Come on. So the second we have is radiant floor heating. So here we have advantages and disadvantages of baseboard radiators. It's quiet operation, does not stir up the air, meaning there is no forced air coming into the room. It's very reliable in terms of if it's done correctly. They hardly ever leak unless the water inside the pipe freeze. Water has very good conductivity and heat capacity than air, meaning that we can transfer more heat through water than air because air does not have as much heat capacity. And you'll see the comparison of heat capacity in the textbook. Radiators are relatively small and they can go around the wall. Some of the advantages are that if you do have a leak, in case of mechanical damage or something else, it can be very problematic because you have water all over the floor. The system is also very slow acting, meaning you turn it on and you wait for at least 20-30 minutes for it to bring in some heat because you need to heat the water, then pump the water around the house. The radiator fins has to be cleaned, and so that's another disadvantage. Cleaning the fins are very, I mean, it's a little bit involved. You have to go inside with a broom and a brush and clean those little fins. And if you don't clean the fins for a long time, they can really reduce the efficiency of that radiator. It cannot be coupled with air cooling, like hot air systems. So that's another disadvantage. It is difficult to place a radiator in a small room. If you have a small room, it's sometimes hard to find a location or a place to put that radiator because you need uh, sometimes proper length of radiator. And for big rooms, you might need a long radiator that will go all around the room, and that's also not something that's preferred. You need to put some furniture, and it could be a little bit of an issue. The heat can damage the furniture if you put it very close to radiator as well. Radiant floor heating is the second system that you can use with hot water system. It has a lot of advantages. It's not visible. This is actually the best, one of the best ways to heat a location for many reasons. One of them is you don't see it. It's very quiet. You don't hear it. It's easy to clean because basically it's inside the floor. So you clean the floor, then you clean the system, and you can flush the fluids from the system once a season or so. It's very easy to flush that system. The heat profile is best for human comfort. The heat profile means that the the heat in the bottom is hot. Usually it's 85 degrees, and it gets cooler around like 5 or 6 feet. 5 feet. If you go to 5 feet, you'll find that it's a little bit cooler around 65. So that's the best heat profile when you have hot floor and cool face level temperature. If you have forced hot air, it's going to be hot in the face and cold at your feet, which you don't want that. It's not really comfortable. And same with other heating system, they heat the air, so the hot air is in the top and the cool air is at the bottom. That's against what we find comfortable. So uh, you can see why would that be very preferred in kitchen and hardwood floor and ceramic tiles. It's very comfortable for the feet to be warm and for the face level to be uh, cooler. That's what we mean by the heat profile. It's best for human comfort. It can be easily zoned through the rooms. Every room will have its own zone. The disadvantage, it is very expensive to install. Not to operate, only to install. Leak can be a major repair if you have, but seriously, the way they are being installed these days, depending on the installer, they're not likely to have a damage. Uh, but they are expensive to install. They are very slow acting. I wouldn't say very, it's just slow acting compared to forced hot air because you have to bring in the entire panel, which is in this case the floor, to a temperature of 85. Then it will start radiating slowly into the room. So, and it's the kind of system that you leave on the entire season. And you can again you can zone it, but it should you should leave it on for a long the entire time because again, if you think about the temperature, the water temperature here, it's 85, which is very low. And that's actually another advantage where you can use small heaters to heat the water, and you don't have to go all the way to 180 or so. Furniture placement can be a problem, and that's going to be a question in the homework where you think about the furniture. So if you have a, if your heating panel is the floor here, so if you put some carpet or like tables, probably this is going to slow down or hinder the heat distribution. Okay. So hopefully that makes sense. Let's move to the next slide. Okay, take this down. Okay, going on. So this is radiant floor heating being coupled with other panels. So you can have radiant floor heating in some surface, and you can have hot water system coupled with that, and some radiators along the way as well to heat the location. So you can mix and match. And I would love to for you to understand that you can mix and match. You cannot have to get fixated on only one type of radiator. You can use things as needed. Okay, forced air system. They are becoming more and more popular, especially that for new houses, since you can have cooling and heating at the same time. And a lot of houses now are requiring more cooling than before because it is getting hotter than it used to. So if you think about the cooling and heating, usually you will like to have a register and a receiver and the dispenser. It's called the receiver. So you can have an in and out, and some in a good installed system, those do reverse. So in the when you are cooling the air, the cold air will come from the top because cold air will fall, so it will kind of improve the circulation in the space. And when you try to heat, you're going to pump the hot air from the bottom and the air will be pulled from the top. It helps the circulation to be able to reverse the in and out of this forced air system. The forced air system can be again coupled. This is a heat pump here, but you can have a furnace, a gas furnace coupled with that. So this will do the cooling, will be a heat pump, and also you'll have an A coil in here. So if we magnify this box here, you'll have something called an A coil, which is can be a condenser or an evaporator based on how you want to reject or bring in heat. And probably you will learn more about that in principle of refrigeration. So a few things I would like to say. Some of the advantages of forced air system. If again, it is a system to distribute heat, and this time you are using air. The duct system has a big factor when it comes to the cost, and there are so many options, and it's good to have the right properly installed and sized forced air system because it does contribute to the noise and it does contribute to the comfort and the circulation of air. You can also filter the air and condition the air in the air handling unit. So this is the air handling unit. You'll hear this term a lot. So everything is centralized. That's what they call it, also a central system. The air gets cooled and conditioned and delivered and sent out from here to the every part of the house. And you can zone things using dampers. So you can have a damper here to close this room, or a damper here to close this room, and balance the air. If you go to big commercial buildings, probably they use a lot of forced air systems, and sometimes they also have chillers. And you'll get more into zoning using conditioned air and filtered air from one central unit. Usually there's one in every floor, depending on how big the building is. And if you work with a hospital, probably you will have a forced air system, and every ward will have its own unit. And a hospital requires constant monitoring of temperature, humidity, and sometimes even particles inside the air. Okay, let me move to the next slide. I think maybe that's it. Let's see. Yeah, so advantages can be used for heating and cooling. Now we're talking about the forced air system. System will filter and condition the air. It is very fast acting. Once you turn it on, it will change the temperature in the room. Disadvantages again, the air flow can be very uncomfortable. People do not like the breeze or the draft, so that could be an issue. And if it's not well designed, it will be very noisy. The air will make a lot of echo inside, a lot of noise inside the duct, and that is not something people prefer. So you can hear the system coming in and off. And as I said in the beginning, the best system is a system that you do not feel or do not hear, but you just feel comfortable. You know the temperature is there, but you do not hear it or feel it or see it. Duct work is very elaborate and can be very expensive. That's one of the disadvantages. And I really try to stay away from the flexible duct because they are very noisy and very impractical. It requires a little bit more maintenance than hydronic system when it comes to duct, filters, and so on. Okay, moving on. So keep in mind at the end of this lecture that there's no one size fits all. It all depends on how do you use it, how often do you use it, what's available, how much money you're willing to invest. So, and everything is possible depending on what you want and what you're comfortable with. It is good to have a variety of heat distributors, even if it might not be a cheaper option. It's good to have an oil, heat, gas, and geothermal together. You can have more options if you have the means, of course. And it's good to have electrical heater in one room, and you have a baseboard radiator in one room, and radiant floor heating in the bathroom and the kitchen. It's good to diversify to give you more to achieve your target, which is having a comfortable temperature throughout the house. Cost, when you think about cost, think of like short term and long term. What is the maintenance cost? What is the operation cost? And how much you are going to put as an investment in that system. Think about zoning, timers, and on demand. They all means to save energy. Having zoning is very good. A room that you do not use, you might want to mothball for the winter and not use it. Timers where you can bring in the heat when you need to, as fast as you need to. And also having on demand water heater, on demand fast acting heaters in one room, etc. Having heat where you need it. That will all help you save energy. And by saving energy, you'll save money eventually, and you have more sufficient heat system or cooling system. Diversity in heating sources is very important, and also think about the material. Think of the passive heating and passive cooling as well. The material, how much does it store heat and how much does it dispense heat? Think also of the material that will reject heat to the outside. Like for example, if you have wall made out of cement, concrete, I mean solid concrete, if the wall is completely solid, probably is going to conduct more heat to the outside, and you might want to insulate that first. Okay, I will see you at the hangout, and please bring any questions or ideas you might have. Thank you very much.